Okay. Hello, and welcome to our second podcast. And we would like to answer a lot of questions about averages.
You're on air, though, with
My name's Jian.
Bailey and Nomi.
Yeah. All right. So, we wanted to answer the question of who's really considered when we say we're talking about an average.
Yeah.
So, on page 45, they tell us that hardly anybody is exactly normal in any way. And this has totally to do with, parents think that it's an issue if their child isn't meeting the norm, but who is considered exactly normal? It's unrealistic for us to believe that children can all be normal. You can't just throw pennies up in the air and have them get
Always
50
do.
heads and 50 tails. It's not realistic.
Another example of that is if you're doing an election poll and you only ask 50-year-olds who they're voting for, that's not representative of who would actually win the election. So, what is average? You gotta include, there's gonna be some variation in people. And you gotta get a sample size that includes people of that variation because your data is only as good as your sample.
Mm-hmm.
I mean, your statistics are only as good as your data.
So overall, everything that you actually get from your quote-unquote average is based on whatever you choose, meaning that if you want a certain type of result, you can just manipulate it to turn it into something that will be more favorable in your position.
That's why we've been talking about standard deviation.
Standard variation.
Standard deviation, because 95% of people will fall in between, this many standard deviations, so people are going to fall within a range, and that's normal for people to fall in a range.
The normal curve. But yeah, and then to talk a little bit about which type of average gives you the best way to compare two classes of this required math course. And my personal favorite is definitely the mean, because you take into account everybody and their scores, and I don't know, it just gives a better range of
You know what? But I think I disagree with that, because in the introduction, they were talking about how when you're selling a house and you're trying to talk about the income of the area, the mean represents something different from the median, which represents something different from the mode. And so it depends. I think it totally depends on
the type of
situation that you're trying to represent, what data it is that you're trying to represent. I think different, the mode, the mean, and the median work better for different data.
I agree with that sense. The mean is you get the mean by adding together all the number, then dividing by the amount of number. That means that if there's one number that is greatly above the others or lower than all the others, the entire thing will be affected.
Mm-hmm.
However, I do believe in most cases the mean is a pretty useful way to actually determine what is the sample. So as much as I like that, I personally prefer the median, simply because you can just find the middle number and just basically roll with it. Because if there's a larger population of people who has lower income and you just find a median, chances are you're going to find somewhere in between the richer people and the poorer people, and it'll be generally leaning towards the more populated side of things, instead of the whole thing being skewed by one or two billionaires that just happens to be living in the area.
I like the mode.
Yeah, mode sounds really good for that type of situation.
Yeah, for trying to represent income in an area, because
it doesn't have as many outliers.
Right, and so there might be a median. That doesn't necessarily mean that that's still representative. I think the mode is representative for that situation, but other situations, different stuff is good.
So I think we all agree on that. Depending on the situation, a different form of finding it will be better.
Yeah.
And depending on how you want to make it look.
All right, now we're going to move on to talking about Chapter 4 a little bit.
All right.
All right, so this chapter was really interesting, and I don't know, it was mostly about estimations and making assumptions based on random events, and it was pretty interesting.
I thought it really connected with one of the quotations in the beginning that said, all round numbers are a lie. because they were talking about like estimation error and stuff like that, and how.
Which is why you shouldn't estimate until the very end.
Mm-hmm.
Or no, shouldn't round to the very
Yeah,
end.
all round numbers are alive. Is the
Yeah.
quote. Who said that?
Samuel Johnson.
Samuel Johnson, a great fella.
Yeah.
Smart fellow.
All right, and then we wanted to talk a little bit about like what dealing like with random questions and stuff like that. This chapter went into the IQ test at first, and it's like, whoa, what does this number mean? And obviously, intelligence like questions like IQ tests are not exactly accurate because some people just test differently and some people just are at different levels, and we're all
Who's normal, right?
What's
we're
normal?
all judged by
I mean, we
that.
all go to
Normal.
SLA. There is no normal.
Let's note first of all that whatever an intelligence test measures is not quite the same thing as we usually mean by intelligence, and neglects such important things such as leadership and creative imagination.
Yeah.
And
And
so,
also the
empathy
core
and
values.
wisdom.
And also the 5
And
core
inquiry,
values.
collaboration, presentation, and reflection.
It defies SLA law.
Yeah.
this is why we don't do IQ tests here.
That's why we're all really low IQs. Just kidding.
All right, just kidding. We're pretty smart people.
Alright,
As
so
you
let's
can
get
tell.
back on topic with Peter and Linda.
What? All right. So actually, we're gonna move on from the IQ test and go to the next example
Okay.
they were bringing up because it was all about like taking random events from a field of corn and like, are we gonna test the quality of the corn based on a few of ears here and there, or are we gonna test the entire field because that would take forever? But
Right.
it's like assumed that if you take a few and they're fine, or if you take a few from different areas and they're not good, then you can make a general assumption. But you need to consider who's, like, which areas might not be as good as others and stuff like that, and yeah.
I think it's important to make sure that you're testing from different areas of the corn.
We're taking a big enough sample.
Right, exactly, because, your statistics are only as good as your data.
But that also has to sort of go through the whole sample size thing. The reason why people do a sample size is going through the actual full set of data is too
Right.
much trouble. So by taking a sample size, that can make everything a lot easier.
But you need
However-
to make sure your sample size is
Is-
representative.
Yes.
So that's really interesting stuff about that.
So the way I see it is that while it does make sense, it sort of contradicts itself since it's trying to find a accurate representation, but at the same time it is sort of skewing it and not really accurate based on the entire thing.
Yeah.
So yeah, but it's an interesting thing.
I agree.
Another big part of this chapter is all about probable error and the issue of making assumptions based on like a certain piece of data, because there's always some amount of like human error or number error or like who's really being tested.
Yeah.
The chapter went into like hypothetical pacing, and then they said something about Stanford by net, and it was the Stanford by net IQ has been found to be 3%, and it has nothing to do with how good the test is. Just like you should consider that your IQ might be better expressed as like the number plus or minus 3. Because there's always some error, like it could be any range. If you have a 98, then it could be any range from like 101 to like 96 or whatever.
So it's more of a
94.
range than an actual number because there's always some sort of error that you might have done. For example, you might have accidentally miscolored the bubble on your IQ test, or there's just some things that's not exactly done the way it should have been, and you just got the wrong answer. But that doesn't mean your IQ is a set number. It just means that you are around the range of that number. So it really doesn't mean much of anything.
Yeah.
Your IQ might look a lot lower than other people on paper, but in truth, you might actually be smarter than the person who got a higher IQ.
Yeah.
All right. Now I think we should move on to chapter 5 now.
All right.
All right.
Because I think we covered most of chapter 4, but let's go. All right, so chapter 5, the Gee Whiz graph. This is all about manipulating graphs to, like, make them look a certain way.
Mm-hmm.
So we did get articles. Mine was from CNN, and it was all about how the Scottish poll about whether or not Scotland should be independent. They made it 52% and 58%. So 110%. That totally makes sense. It's pretty genius. CNN, whatever.
The graph that I found in chapter 5, they were talking about like the proportion of the y-axis or the x-axis, and how you can use that to distort things. And it's really easy to do with modern software. For example, in my article from Fox News, they were talking about Obamacare enrollment, and obviously Fox News doesn't like Obamacare, so they've got a hidden agenda here. And they want to represent Obamacare like it's failing. So what they did was they zoomed way in on the y-axis to make it seem like there was a big difference between the goal of the people that they wanted to register and how many people actually registered. So as of March 27th, 6 million people have registered, and their goal was 7 million people as of March 31st, which isn't actually they're not that too far off. But since the y-axis was distorted and scaled so much that it made it seem like they were like 5 times off their goal, and technically they weren't lying with the graph, but because it was so zoomed in, they didn't say anything, but
you have to make note of
distortion.
And then we had this article from Gizmodo, and they told us also about how the y-axis changes, and they made like 4%, 4.6% look like 80 or 90% difference, and that's totally different. It's just having to pay attention to the y-axis because it can totally change what the graph looks like.
So the article that I found was from a website called Forbes, or however it's supposed to be pronounced.
Forbes, the financial magazine.
Forbes or Forbes. It's bees. It's bees.
No, it's Forbes.
But whatever. It's written by a person named Nomi Robbins, and it's talking about Facebook and how much the value of the company is. What they showed was basically the same as others. It is manipulating the y-axis. What they did was basically they cut off most of the bottom part and just left the very tip top of it, showing that apparently their values increased so much over the years when actually it's not really that much difference. Simply because they cut out most of the bottom chart, it makes it look like their very first year is really, really low compared to all the other years. But if you add them back in and just zoom out a bit, it's really not that big of a difference. But because of what they did, it looks really, really different.
That's exactly what happened in the book.
They were talking about that in chapter 5.
They have 2 images right here.
Can I just mention that the second one is really, really freaky?
Yeah.
What? Oh, because the face is all
He's staring into your soul.
Distorted. And
anyway, so Bailey, what were you saying?
I was gonna go into just to the big example that brings this all together is about if you zoom in or zoom out on a graph, it makes it look like a lot bigger difference than it actually is. Mostly zooming in because that just brings it all into proportion.
The way that you can make graphs misleading is by your choice of ranges, your choice of proportion on y-axis and x-axis, and also distorting bar charts by having them start at positive values or trimming them below an artificial baseline to 0.
Also, manipulating the graph to only show a portion of the big picture which is a lot of what Fox News does.
Fox News,
it
the most reliable source.
It allows you to bring the viewers onto a specific side, and you can make it without showing them the other part of the situation, and that's not cool. You're messing with people, but whatever. Yeah.
I want to bring it back to sample size. So I think that one of the reasons why advertisers rely on small sample sizes is because they're trying to do the same thing that people who distort graphs do, is that they're trying to mislead people. We were talking about the importance of having a large sample size, and I think that it's similar to the graph, that you need to have an accurate graph, and you need to have a large sample size, because advertisers will use small sample sizes and inaccurate graphs to try to get you to buy their product.
That's freaking awesome. Why did I curse? I don't know. Okay. I think that brings us to the end of this discussion right here. That was pretty amazing, guys. All right. Goodbye, Mr. Mouse. See you next time.
All right, bye.
Signing off.
Woo!